Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have finished properties of aldehyde and ketones, and also I discussed uses of aldehyde and ketones. Now I am going to start carboxylic acids. Carboxylic acids. What is carboxylic acid? Already many times I have discussed, but now it is the right place to tell about the carboxylic acids in details. Carbon compounds containing a carboxyl functional group means COOH are called carboxylic acids. Carbon compounds containing a carboxyl functional group means COOH are called carboxylic acids. The carboxylic group consists of a carbonyl group attached to a hydroxyl group. Means in carboxyl group, two groups are present. First CO group and other OH group. CO group and OH group both are attached. Okay, the carboxyl group consists of carbonyl group attached to a hydroxyl group. Hence its name carboxyl. Carboxylic acids may be aliphatic or aromatic depending on the group. Alkyl or aryl attached to carboxylic carbon. Carboxylic acids may be aliphatic or aromatic depending on the group. Alkyl or aryl attached to carboxylic carbon. Large number of carboxylic acids are found in nature. Some higher members of aliphatic carboxylic acids means carbon number 12 to carbon number 18 known as fatty acids. Again you listen, this is a very important point. Some higher members of aliphatic carboxylic acids means C12 to C18 number of carbon atom 12 to number of carbon atom 18 known as fatty acids. These occur in natural fats as ester of glycerol. Some higher members of aliphatic carboxylic acids known as fatty acids occur in natural fats as esters of glycerol. Carboxylic acids serve as a starting material for several other important organic compounds such as anhydride, esters, acid chloride, amide, etc. Now I am going to discuss nomenclature and structure of carboxylic group or carboxyl group. Since carboxylic acids are among us the earliest organic compounds to be isolated from nature, a large number of them are known by their common names. The common names end with the suffix ic acid, IC acids, and have been derived from Latin or Greek names of their natural sources. For example, formic acid, HCOOH, formic acid was first obtained from red ants. Latin word is formica. Formica means ant. Acetic acid, CH3COOH, from vinegar. Latin word is acetum. means vinegar. Butyric acid, that is the CH3, CH2, CH2, COOH from rancid butter. Rancid butter. Latin word, it came from the Latin word butrum. Butrum means butter. Butyrum. Butrum means butter. In the IUPAC system, aliphatic carboxylic acids are named by replacing the ending E in the name of the corresponding alkane with oic acid. Oic acid. In numbering the carbon chain, the carboxylic carbon is numbered 1. For naming compounds containing more than one carboxyl group, the ending E of the alkane is retained. Again you listen. For naming compounds containing more than one carboxyl group, the ending E of the alkane is retained. The number of carboxyl groups are indicated by adding multiplicative prefix like di, tri, etc. to the term oic. This di, tri, etc. If multiple carboxylic groups are present, then these groups are indicated by adding the multiplicative prefix di, tri, etc. to the term oic. The position of COOH group are indicated by Arabic numeral before the multiplicative prefix. Some examples I am telling you. This naming, how nomenclature is done, I will tell you with some example. First example is formic acid, HCOOH, formic acid. Common name is formic acid. And what is the IUPAC name? Then here you can see only one carbon is there, HCOOH. COOH a carboxylic group or carboxyl functional group. Okay. Then here only one carbon is there. That's why its IUPAC name is methanoic. Methanoic acid. This is the IUPAC name of formic acid, means HCOOH. Methanoic, OIC, methanoic. E you have removed, methane, METHANE. E is not there. E you have removed, OIC you have added, methanoic acid. Now another example, that is the acetic acid, CH3COOH. Here two carbons are there. Then common name is acetic acid. And IUPAC name is, because two carbon is there, hence for two carbon, ethane name is the ethane. But here it is a COOH group is attached. And total including COOH, that C total is two carbon, CH3 COOH. Then it is called ethanoic acid. Ethane, E you have removed, OIC you have added, ethanoic acid. Like that way, propionic acid, propionic acid, CH3CH2 COOH, propionic acid. This common name is propionic acid, CH3CH2 COOH. Now total 3 carbon is there. Then now its IUPAC name will be propanoic acid. Propane, propane word E has gone and OIC added in its place. Propanoic acid. Like that way, butyric acid. Butyric acid means now 4 carbons are there, CH3, CH2, CH2, COOH. Common name is butyric acid, and IUPAC name is butanoic acid. Butane, E gone, OIC added in its place. Butanoic acid. Now another example I am telling you. Now here CH3 whole 2, CH, COOH. How many carbons are there? Then name itself is there. Common name is isobutyric acid. CH3 whole 2 means one CH3 in the form of a branch, and one CH3 is attached with other C. And CH3, with that CH3, one CH3 is attached, and CH3 is attached to CH, and that CH is attached to COOH. Means total 4 carbons are there. One is in a branch form, methyl group. That's why its name is isobutyric acid. And what is the IUPAC name? Then carbon number 2, methyl group is attached. At carbon number 2, methyl group is attached. That's why its name is 2-methyl propanoic acid. Total 4 carbons are there, but one is methyl group, CH3. Hence, main branch is propane. Then E gone, OIC added. In the place of E, OIC came. Then name will be, IUPAC name will be 2-methyl propanoic acid. Now, another example I am telling you, that is oxalic acid, COOH, again COOH, and both C is attached with single bond. COOH, left side, right side again COOH. In the middle, bond is there, single bond. Or you can write COOH whole 2. That also you can write. But here, for naming purpose, you can write COOH and single bond again COOH. Then now here, how many carbons are there? Then 2 carbons are there, and its common name is oxalic acid. Oxalic acid. And now 2 carbon is there, hence IUPAC name will be ethane dioic acid, because 2 COOH group is there. COOH is in 2 number, COOH. Hence its IUPAC name will be ethane dioic acid. Now you can see, when two acid group is attached, COOH, that time you have to write full name, alkane name you have to write, means ethane you have to write, and then 2 COOH group is there, hence you can write di, and then OIC, oic, ethane dioic. If more than one COOH group is there, then you write alkane name full. Then ethane dioic acid. Now next carbon I am telling you, that is actually malonic acid. This is the common name, COOH. In the middle, CH2 is there. Means with CH2, 2 COOH group is attached. In the middle, CH2 is there. Means total 3 carbon is there. Total. Then its common name is malonic acid. Then now, because the total 3 carbons are there, COOH, CH2, again COOH. Total 3 carbon is there. Hence, because here 2 COOH group is there, then just like above what I discussed, it will be propane, full name, alkane name propane, then OIC, oic acid. Propane dioic acid. Very easy to write the nomenclature, write the IUPAC name. Now another example, in the middle only one CS2 group was there. Now another example, now consider in the middle two CS2 group is there, CS2 whole 2, and both side COOH is attached, means 2 carboxylic. Then now total 4 carbons are there. Then common name is a succinic acid, very very important acid, succinic acid. COOH in the COOH one side, other side again COOH, in the middle CS2 whole 2, total 4 carbons. And a name is very easy, IUPAC name you can write very easily, butane dioic acid. If COOH group is there, whether it is a 2 or 3 or 4, finally it will be acid. Now next example I am telling you, that is a glutaric acid. Now in the middle 3 CS2 is there, CS2 whole 3, CS2, correct? Left side you can write directly CS2 whole 3, then one side COOH, other side again COOH, means 2 carboxylic group is there. Okay, then here again easily you can do nomenclature. Its common name is succinic acid, but here how many in this glutaric acid I am talking about, there are 3 CS2 group and 2 COOH group. Left side, right side, COH, in the middle 3. Then 3 means here total 5 carbons are there. Then its common name is glutaric acid, and because 5 carbons are there, then again name will be very easy. 5 carbon means pentane, then pentane dioic acid. Just like succinic acid, CS2 whole 2 and 2 COOH group was there, then total 4 carbon was there. That time you have written butane dioic acid. Now 5 carbons are there in glutaric acid, CS2 whole 3, both side COH. Then this glutaric acid IUPAC name is pentane dioic acid. Like that way, if 4 CH2 is there in the middle, CS2 whole 4, and left side COOH, right side COOH, means 2 carboxylic group, then this is actually common name is adipic acid, and total 6 carbon is there. Then IUPAC name will be hexane dioic acid. Now one I am giving example, their common name is not there, directly you can write IUPAC name. Then here 3 carboxylic group is attached, 3 COOH group is attached, 3 COOH group is there. Then here carbon number 1, carbon number 2 and carbon number 3 COOH group is attached. Then numbering, you know how will start, then you will start from the COOH group, near to that carbon, that will be 1, after that 2, and last will be 3. Here 3 CH2 was there, then with first CH2, first carbon COOH group is there, and only with this CH2, with this not with this, with this CH2 group only 1 carboxylic group is attached, COOH, and with this after that second CH2 is there, then 1 H gone, and in its place COOH is attached, that is with second carbon COOH is attached, then only CH is remaining with second carbon, and third carbon CH2 is there, and always last carbon will be CH3. Last carbon or first carbon generally it will be, if it is alkane then it will be 3 CH3, but here last carbon 2 hydrogen is there, then third one is COOH. means 3 COOH is at 3 different carbon atom, means 3 COOH is attached. Then now here what will be the IUPAC name? Then actually in the propane 3 CH2 was there, CH2, CH2, CH2. Then with the middle CH2 one H gone and COOH came. Then first and last one carbon it should be CH3, but one H from both gone and COOH attached, COOH group attached. Hence in propane 3 carboxylic group is attached. Okay, carboxyl group is attached 3. Then here name will be very simple way, because it was a 3 carbon, then it is the propane, and again 1, 2, 3 tricarboxylic acid, okay. Carboxylic is used, carboxylic word is used for acid, carboxylic acid, but carboxyl group is for COOH, that group is called carboxyl group, okay. But if you want to tell the name as a acid, then you tell carboxylic acid, and CO group is called carbonyl. All three, CO group is okay, carbonyl, but CO and OH both you are telling, then that is called carboxyl, XYL. But if you want to tell in the form of acid, like formic acid, acetic acid, propanic acid, then you can say carboxylic, IC, carboxylic, LY, carboxylic, XYLIC. Then here 3 acid is there, then acid group, carboxyl group, then you can tell propane 1, 2, 3 tricarboxylic acid, okay. Now next example I am telling you, that is related to aromatic group. Now suppose in benzene ring COOH group is attached, carboxyl group is attached, group is carboxyl, okay. Then now here name will be benzoic acid. In benzene COOH group is attached, that is common name is benzoic acid, and IUPAC name is, already I discussed earlier, again I am telling you, benzene carboxylic acid, also called benzoic acid. Benzoic acid is common name as well as IUPAC name. Then benzoic acid is also called benzene carboxylic acid. Now suppose with this benzene ring CH2 COOH group is attached, CH2 COOH group is attached to the benzene. Not COOH is not directly to benzene, COOH is attached to CH2 and that CH2 is attached with benzene ring. Then this is called phenyl acetic acid. Phenyl acetic acid, because CH3COOH, that is the acetic acid. Then only from that acetic acid one H gone. Then now 2 H is remaining, CH2, and in its place one H gone, in its place phenyl group attached. Correct? CH3COOH, then one H gone, and in its place phenyl group has come. Then now it became benzene ring, after that CH2 and then COOH. Then its name, common name is phenyl acetic acid. And IUPAC name will be, that will be 2-phenyl ethanoic acid. 2-phenyl ethanoic acid. Then now we will tell why this name 2, from where the word 2 came. Then here you can 2-phenyl ethanoic acid. Then how 2 came, you have to understand. Then here you can see acetic acid CH3, COOH was there. Then carbon is number 1 and CH2, carbon number 2. With this carbon, phenyl group is attached. That's why it is called, phenyl is attached to carbon number 2. That's why it is called 2-phenyl ethanoic acid. 2-phenyl ethanoic acid. Now, third example I am telling you. Now 2-carboxylic acid is attached here. Then it will be called thylic acid. PHTHALIC, thylic acid. 2 carboxylic group is attached adjacent to each other. Correct? Means in respect to one, other is at alpha position. Or if you consider one, other will be 2. Then its common name is thylic acid. And IUPAC name is benzene. Carbon number 1 and 2, carboxylic acid is there. That's why its name is benzene 1,2-dicarboxylic acid. 1,2-dicarboxylic acid. Now come to the structure of carboxyl group. Structure. Then already many times I have discussed, but it is the right place to discuss. I am telling you in details. Structure of carboxyl group. Then carboxyl group is it is C double bond O and OH. C with the C double bond O is there, and with that C OH is attached. C and O single bond is there. That second oxygen that is attached with carbon with single bond. Correct? And O is attached with H. Hence it became C double bond O OH. Then second oxygen is single bond. One oxygen is double bond, other is single bond. Okay, OH. Then now here you can see that this structure, how can you write that? I am telling you a structure. In carboxylic acid, the bonds to carboxyl carbon lie in the plane. First important point. The bonds to the carboxyl carbon lie in one plane and are separated by about 120 degree. Because this, what is the angle? Angle also you know. Then it is separated by 120 degree. The carboxylic carbon is less electrophilic than carbonyl carbon. The carboxylic carbon is less electrophilic than carbonyl carbon. Carbon, oxygen double bond is there, that is a carbonyl carbon. Correct? But here talking about the carboxylic carbon. The carboxylic carbon is less electrophilic than carbonyl carbon. Why? Because the possible resonance structure, I am telling you a structure, possible you can say resonance structure is that what will happen, that actually in CO group, carbonyl group, only C and O bond is there, double bond. Second oxygen is not there. Correct? In carbonyl group, C double bond O, only one oxygen is there. But in here, two oxygens are there. One oxygen is attached with carbon with double bond, another oxygen with single bond. Hence, its structure will be possible resonance structure. I am telling you that if a double bond will break, if double bond will become single bond, then oxygen will take negative electron. Oxygen will take the electron and will become negative. Bonded electron will be taken by oxygen and it will become negative, and carbon will become positive. Why? Because carbon electron also taken by oxygen, because in bond both have shared one electron. Carbon 1 electron, oxygen 1 electron. Both electron is taken by oxygen and became negative, and carbon became positive because it lost the electron. This is the second structure. Now third structure, what will happen, that now you can see where single bond was there, that was the OH, then now that oxygen has a 2 lone pair of electron. Oxygen has a 2 lone pair of electron, OH bond is there. Then what will happen here, that OH bond was attached to carbon with single. Now that bond is becoming a double. How? Then oxygen was having 2 lone pair of electron, it has given 1 lone pair of electron to the carbon. Carbon was positive, correct? Then for making 1 bond, 2 electron is required. Then this 2 electron is given by oxygen, lone pair. Because carbon was positive, its electron was taken by first oxygen. That's why now single bond became double bond. Correct? Then now it is the third structure. Then see here, where bond was double, that became single, and where it was the single, that bond became double. See double bond O, now it became single bond, and which was the single bond, COH, that became double bond. Correct? Then now here you can see what happened. Then like that way you can say this is the, you can say, resonance structure. This is the 3 structure is there. Then now due to this region, now carboxylic carbon is less electrophilic than carbonyl carbon because of the resonance structures. Okay. Now I am telling these things, methods of preparation of carboxylic acid. Methods of preparation of carboxylic acids. First methods I am telling you, from primary alcohol and aldehydes. Actually methods are easy to understand. Primary alcohols are readily oxidized to carboxylic acids with common oxidizing agents such as potassium permanganate in neutral acidic or alkaline media, or by potassium dichromate and chromium trioxide. Chromium trioxide means CrO3 in acidic medium. Okay, easily you can make this, many times I have discussed. Then primary alcohols are readily oxidized to carboxylic acids with common oxidizing agents such as potassium permanganate in neutral acidic or alkaline media, or by potassium dichromate means K2Cr2O7, and also in presence of chromium trioxide in acidic media. Reactions are very easy. RCH2OH is the alcohol. In presence of alkaline KMNO4, what will happen here? It will give RCOOH. Correct? First H2 will go as H2O, and 1 oxygen will be in the place of 2 hydrogen, 1 oxygen will come. Correct? RCH2OH was there. Then this H2, that H2 will be replaced by 1 oxygen. Then now it will become RCOOH. In the beginning 1 oxygen was there. Now it became 2 oxygen. Now you can see other example I am telling you. Long chain, same things, RCH2OH is there. Here also CH2O is there. CH2OH is there. But in the place of R, you can decanyl group, it is attached. Decanyl. Then CH3CH2 whole 8 CH2OH. Then this is important, is the last CH2OH. From this CH2OH, CH3 CH2 whole 8. Total 10 carbon is there. 8 plus one CH3, that is the 9, and 1 CH2, that carbon 10. Then actually alcohol name is 1-decanol. 1-decanol. Then this CH3 CH2 whole 8, leave it, and CH2OH OH. Then here again CH2 will H2 will go and O will come. Then that decal will be same, but now name will be decanoic acid. Decan, E will go, OIC will come, will attach. Hence it is called decanoic acid. But this will take place in presence of CrO3. CrO3 in presence chromic acid in presence of acid like H2SO4. Correct? This I have told you, that is the preparation by alcohol. Okay, carboxylic acids are also prepared from aldehyde by the use of mild oxidizing agent. Many times I told you, there also H will go, CHO, C double O, H is there, then there what will happen? One oxygen will introduce. Then C double O H is there, CHO. Then how it will go? How oxygen will introduce? Then double bond will break. Correct? Double bond will become single bond. Single bond. Then and carbon will come. Carbon will become this things, positive. Positive. Then now CHO, that H will go. That H will go as H plus. It will attach to the O minus, which has taken the electron. That become OH. OH. Then now two carbons are two positive charges there on carbon. Two positive charge. Then just to satisfy, to neutralize this positive charge, one oxygen will attach. You know, oxygen have two electron. Then that will make a double bond. Then now it becomes COOH. Then now same way RCHO, now it became RCOOH. Now next example I am telling you, a next reaction, preparation from alkyl benzene. From alkyl benzene, aromatic carboxylic acid can be prepared by vigorous oxidation of alkyl benzene with chromic acid or acidic or alkaline potassium permanganate. Okay, aromatic carboxylic acids can be prepared by vigorous oxidation of alkyl benzenes with chromic acid or acidic or alkaline potassium permanganate. The entire side chain is oxidized to the carboxyl group irrespective of length of the side chain. Primary and secondary alkyl groups are oxidized in this manner, while tertiary group is not affected. Suitably substituted alkenes are also oxidized to the carboxylic acids with those oxidizing agents. Okay, then reaction I am telling you, two reaction I will tell you. Suppose it is the toluene, CH3 is attached to benzene. Then if you will heat toluene with KMNO4, means alkaline KMNO4, and if you will heat it, then these CH3 will convert to COO. 3H was there, then now two oxygen introduced, correct? CH3 was there, then now two hydrogen gone, then one oxygen came, correct? One oxygen came, then one oxygen attached. Now one hydrogen is there, two hydrogen out of three hydrogen, two hydrogen gone, and one oxygen came. Now one hydrogen is there with carbon, then that H again it will go. Then that H will go as a, it will go as a H plus. Then now what will happen here? One O has to introduce. Then this CO group now just introduced with double bond, that will become the single bond. Then oxygen will be negative, carbon will be positive. Then now here you can see this H means H, now what is going, 2H already gone, then one oxygen came. Now third hydrogen when it went as H plus, that came to this oxygen O negative, and it formed OH. Then now carbon has 2 positive. Then now new oxygen will go and it will make double bond. Then now two hydrogen introduced, C double bond O, and earlier which was the double, now it became O, single bond, that is the OH. Like that way acid is introduced. But here, because you are using KOH and KMNO for oxidizing agent, then it will make one intermediate, that is the COOK, because you are taking KOH, you are not taking you can say acid. If you will take acid, directly it will be OH. If you are taking KOH, then in the place of H, K will go, and next after hydrolysis that H will come. K will go, and it will go as a K plus, but H plus can replace. Then it will form COOH group, means benzoic acid, because it was toluene, it was CH3 was attached to benzene. Then now that CH3 converted to COOH. This is called benzoic acid. Now one more example I am telling you, that is the now CH2 CH3, means propyl group is attached to the benzene. Propyl group is attached to the benzene ring. Then on heating in presence of KMNO4, KOH, means alkaline, in presence of alkaline KMNO4, this compound will give same way it will convert to COOK. Okay, because three are there, three carbons are CH2, CH2, CH3. Then how it will go? Only this will go, it will break, only one CH3 will actually, it will remain. 2 CH2, it will go. Okay, it may go as alcohol. CH2, CH2, CH3. CH2 is there, OH group can attach here. Correct? CH3, CH2, OH. It will go as a ethyl alcohol. Then now this thing, what will remain? CH2, CH3. Then CH3, CH2. Correct? It requires one oxygen, one hydrogen. Then O will come from the oxidizing agent, and H will come from where? Then it will come from the this alkaline medium. Then now 2H is CH2 is remaining, then now what will happen, that 2H2 will also go, because oxidizing agent is there, it will go as a H2O, H2 plus O, H2O, and another again third oxygen will join there, COO. And you know that like what I discussed earlier, that carbon, that is the COO bond will be there, then that will break, that will convert to single bond, carbon will come positive and oxygen will negative. Then this I told, when 2 hydrogen will go, that time 1 oxygen will join, but third one hydrogen when it will leave, then that time carbon will come again negative, carbon will become negative and hydrogen will become positive. Then this actually, that now these things when COO bond will break, will convert these things to single bond, double bond convert to single bond. Then oxygen will be negative, carbon will be positive. Then with this positive, now another oxygen will come. Correct? 2 positive is there, then 1 oxygen can come, and 1 oxygen is negatively charged. Oxygen is negatively charged. Then that hydrogen which went as a H plus, that will come to that oxygen. Then that will come OH. And now that converted to COOH. Very easy mechanism. Double bond become single bond. Then oxygen become negative. Carbon become having 2 positive. Okay, positively charged. Then oxygen will come from the oxidizing agent, that will make a double bond. And O which was negative, then hydrogen H plus, either from the water or now only from that CH3 was there. Then when all 3 will H will go, then third H will go, that is H plus, that will join to the oxygen. Then it will form COOH, that is the benzoic acid. Again it will form benzoic acid. Okay, now I am stopping only here. And now other methods are there, preparation, that I will discuss next class. Okay, and also I will try to discuss some these things, chemical, physical properties I will try to discuss next class. Thank you.